Welcome back to Miss G's Math channel. If you have not subscribed yet, please do subscribe today. How do we graph solution sets of inequalities? Let us demonstrate this using example 1. Graph the solution set of a greater than -5 and b less than 4. There are many values of a that make a greater than -5 true. All numbers greater than -5 will make the inequality true. We can show this on a number line. Any point to the right of the coordinate -5 is greater than -5. Let's draw an arrow to show all such points. Notice that we're drawing an open circle. This means that -5 is not in the solution set because -5 is not greater than -5. This means that the solution set of a greater than -5 is an infinite set of all numbers greater than -5. What about b less than 4? In the same way, let's draw a number line. Any point less than the coordinate 4 is a solution to the inequality b less than 4. Also notice that we're going to use an open circle to draw the arrow because 4 is not part of the solution set. Let's draw an open circle above the coordinate 4 and draw an arrow to the left of 4 because it's less than. So the solution set of b less than 4 is an infinite set of all numbers less than 4. Let us look at example number 2. Graph the solution set of x less than equal to 7 and -4 less than equal to b. Notice that this time we are using a less than equal to b and a greater than equal to b. So we will be using a dot or a closed circle, which means that b is part of the solution set. Graph the solution set of x less than equal to 7. The solution set of x less than equal to 7 is the set of all numbers less than or equal to 7. This is shown on the number line as all numbers, including 7, to the left of 7 are part of the solution set. Let's draw an arrow to the left of the coordinate 7. Notice that this time we're going to use a dot because 7 is equal to 7, and so it's part of the solution set. The solution set of x less than equal to 7 is an infinite set of all numbers less than equal to 7. As for -4 less than equal to b, it is easier to graph the solution set of an inequality like -4 less than equal to b if you rewrite the inequality with a variable first. So let's rewrite -4 less than equal to b to b greater than equal to -4. Let's draw an arrow starting from -4. Start with a dot or a closed circle, and then draw the arrow to the right of -4. The solution set of -4 less than equal to b is an infinite set of all numbers greater than equal to -4. In the next examples, we will be studying the inequality properties. Specifically, we are going to write a true inequality by performing a given operation on each side of the inequality. For example 3, we're going to write a true inequality by adding the indicated number to each side of the given inequality. Add 7 to each side of 5 greater than equal to -2. This will result to the new inequality 13 greater than equal to 5. Is this true? Yes, 13 is greater than equal to 5. You also notice that the inequality symbol in both 5 greater than equal to negative 2 and 13 greater than equal to 5 is the same greater than equal to. These two inequalities are said to have the same order. Let's look at another example. Add negative 4 to each side of negative 7 greater than equal to negative 10. Take note, we are adding a negative number to both sides. This would result to negative 7 plus negative 4 equal to negative 11 greater than equal to negative 14. Is negative 11 greater than equal to negative 14? Yes, negative 11 is greater than negative 14. So this is a true inequality, and both the original negative 7 greater than equal to negative 10 and negative 11 greater than equal to negative 14 have the same order. The two examples are both true inequalities. What does this mean? Example 3 shows that adding the same number to each side of an inequality does not change the order of the inequality. That is the first property. Adding the indicated number to each side of the given inequality preserves the order of the inequality. For example 3b, let's find out what happens when we subtract the same number from each side of a given inequality. Subtract 7 from each side of 5 greater than equal to negative 2. Let's do it horizontally. 5 minus 7 and negative 2 minus 7 would give us negative 2 greater than equal to negative 9. Is this a true inequality? Yes, it is true. Negative 2 is greater than negative 9, and negative 2 greater than equal to negative 9 has the same order as the original inequality 5 greater than equal to negative 2. Let's look at the second example. Subtract negative 7 from each side of negative 7 greater than equal to negative 10. We do this horizontally again. So negative 7 minus negative 7 is greater than equal to negative 10 minus negative 7. Negative 7, and then you have minus and negative, gives us a positive. Therefore, negative 7 plus 7 would give us a 0, greater than equal to negative 10 plus 7 equals negative 3. 0 greater than equal to negative 3 is a true inequality, and it has the same order as negative 7 greater than equal to negative 10. These two examples illustrate that subtracting the same number from each side of a given inequality does not change the order of an inequality. Just like addition, subtraction preserves the order of the original inequality. This time we are going to learn what will happen when we multiply a positive number to each side of the given inequality. Multiply each side of 5 greater than equal to 2 by 3. 5 times 3 greater than equal to 2 times 3 would give us 15 greater than equal to 6, which is a true inequality because 15 is greater than 6. and 15 greater than equal to 6 has the same order as the original inequality 5 greater than equal to 2. What happens if we multiply 3 to inequalities consisting of negative numbers? So multiply each side of negative 7 greater than equal to negative 10 by positive 3. Negative 7 times positive 3 and negative 10 times positive 3 would give us negative 21 greater than equal to negative 30. Negative 21 is greater than negative 30. So this is a true inequality. That means that negative 7 greater than equal to negative 10 has the same order as the resulting inequality negative 21 greater than equal to negative 30. What does this mean? Both examples have the same order, which illustrates that multiplying each side of an inequality by a positive number does not change the order of an inequality. What will happen when we multiply a negative number to each side of an inequality? Let's see. Multiply each side of 5 greater than equal to 2 by negative 3. 5 times negative 3 greater than equal to 2 times negative 3 should give us negative 15 and negative 6. What is the relationship between negative 15 and negative 6? Is negative 15 greater than negative 6? This is not a true inequality. Therefore, we are going to reverse the order of greater than equal to less than equal to. We should have negative 15 less than equal to negative 6. So when we multiplied both sides of the original inequality by a negative number, we reversed the order of the resulting inequality from greater than equal to less than equal to. Let's have another example. Multiply each side of negative 7 greater than equal to negative 10 by negative 3. Negative 7 times negative 3, is it greater than equal to negative 10 times negative 3? The resulting inequality should be positive 21 and positive 30. What's the relationship between 21 and 30? Is 21 greater than 30? That's not true. So we are going to reverse the inequality from greater than equal to less than equal to. 21 less than equal to 30. This is a reversed order. What does this illustrate as a property of inequality? This shows that when you multiply a negative number to each side of a given inequality, you're going to produce an inequality of reversed order. So a negative number produces an inequality of reversed order. From the original greater than equal to, it will change to less than equal to. Or if the original inequality is less than equal to, it will become greater than equal to whenever you multiply the original inequality with a negative number. Write a true inequality by dividing the indicated number to each side of the given inequality. Since division is related to multiplication, it would seem that the division properties of inequalities would be the same as those for multiplication. So let's divide each side of negative 8 less than equal to 12 by positive 4. This should give us negative 2 and 3. What is the relationship between negative 2 and 3? Negative 2 is less than 3. Therefore, the order is preserved. Negative 2 less than equal to positive 3 has the same order as negative 8 less than equal to 12. This means that when we divide each side of an inequality by the same positive number, we are going to keep the same order. For the second example, divide each side of negative 8 less than equal to 12 by negative 4. This would result to a positive 2 and a negative 3. Is positive 2 less than equal to a negative 3? This is not a true inequality. Therefore, we have to reverse the order of less than equal to greater than equal to. 2 is greater than equal to negative 3. This is a reversed order of the original inequality because we divided each side of the original inequality by a negative number. What does this mean? Okay, the example 6 shows that dividing each side of an inequality with a positive number produces an inequality of the same order, while dividing each side of an inequality by a negative number produces an inequality of reversed order. So the less than equal to becomes greater than equal to, and if the starting inequality is less than equal to, it would be reversed to greater than equal to when you divide both sides of the inequality by a negative 4. So multiplication and division do share the same properties of inequality. Let us now summarize the properties of inequalities when we perform a given operation on each side of the inequality. We learned from examples that adding the same number to or subtracting the same number from each side of an inequality produces an inequality of the same order. On the other hand, multiplying or dividing each side of an inequality by a positive number produces an inequality of the same order. Multiplying or dividing each side of an inequality by a negative number produces an inequality of reversed order. Thank you for watching. See you in our next video. Don't forget to subscribe or give a comment below.